Hello there and welcome to a new lesson. In this one we're going to be setting up both the player and the enemy. And for this we'll actually have to create the two main rooms, basically both the menu and the game room. So we only have this room currently, so I will rename it by right clicking and here rename, and I will call it RM menu. Okay? Then I will right click on here again and I will click duplicate and I will call it RM game. Something I have to note here is this home icon over here. This basically determines which is the main room, basically which is the room that is run when the game starts. Because when the game starts, GameMaker doesn't really know which room to play from all the rooms that you may have. So you have to find the home room. In this case, it is okay because mostly any game starts in the menu. But well, if you wanted to modify this, you can click on this icon over here, and well, here by using these arrows, you will be able to modify your main room. But well, we have to make sure that the main room is the menu. Okay. Now make sure that you are able to differentiate these two rooms because well, right now they have the exact same elements. Okay. But well, then we will actually get to in the menu draw the texts, draw the button and more stuff. But well, right now they look the same. And for example, for when we are going to be putting the enemy and the player, well, we'll actually be doing all that in the room game. So make sure that you are in the game room. So to start setting up both the enemy and the player, we need the sprites. So here in the sprites folder, I will right click and I will create a new group. This is basically a new folder, okay, and I'll call it units. This is just so that I have everything a little bit better organized. And I will right click here, I will click create, and here we'll create a sprite, okay. I'm going to be calling it SPR player, and I will create other sprites that I'm going to be calling it SPR enemy. Now let's do the same thing but in the objects. So in the objects I will create a new group that I will call units. Then I will right click inside of here and I will create the two objects. So obj enemy and create object obj player. Now I will go to each of these objects and load in the corresponding sprite. So in the enemy, I will load in the enemy sprite, and in the player, I will load in the player. Then I will go to the sprite's enemy and I will import the corresponding image. So assets, images, and this was the enemy. So here I have the enemy and I will do the same thing but with the player. So now our objects are both set up correctly. Now also something else that we're going to be doing is modifying the anchors of these sprites, because by default they are on the top left, but in most cases for positioning them on the screen, then for the pathfinding system, for the collision system, for the movement system, and for more things that the game will be having, it is much easier to just have all the anchors in the center. And in reality, for most usages in GameMaker, it is usually better to just have the anchors on the center of it, okay? It just makes calculations and behaviors much easier to create. So I will put all the anchors in the middle center, okay, at least of the player and the enemy, just to make sure that then when we position it, move them, whatever, that they work as we want. This will make a little bit much more sense when we get to the enemy AI pathfinding system. Now, making sure that you are on the room game and not in the room menu, I will go to the instances layer and I will drag and drop some of these objects. Okay, so for example, I will drag and drop over here one player, and as you can see, we don't see it because of the order of the layers. So I will move the tiles below my instances layer, so there I will see my player, because actually how GameMaker renders layers is that Firstly it draws the background, okay, and then in this case it is drawing the tiles, and then on top of the tiles it is drawing the instances, being the player in this case. So it is always drawing from the bottom to the top, okay. And I will put, for example, here some more players, for something like this, and I will also put 3 enemies, okay, something like this. Then of course with the following lessons we'll get to code their behaviors, but well, at least we have completed here the super basic setup so that we can at least see it in the screen, and we have successfully set up the object and the sprite for both of the units, okay. And with this lesson is finished, so I will see you in the next one. Hi there and welcome to this new lesson. In this one we're going to be covering how to create the manager object and also the init script. First of all, what is the manager object? So it is basically going to be an object that is going to be completely empty in terms of sprite, collision, etc. So it isn't an object that, for example, we are going to be able to see in the scene and that we are going to be able to move around. The manager object actually is going to just basically be storing some variables and some information that then we are going to be using inside of the game. These are basically global variables, which means that basically are going to be accessed in any object that we create. Because, well, for example, right here, we don't have any kind of code yet, but if we have a variable inside of the obj player, okay, that variable, it is only going to be existing inside of the player object. But if we have a global variable, that variable is going to be accessed in any other object, in the enemy, in the player, in literally any other object. Technically, you could avoid using a manager object and just declare these global variables in the player, for example, or in the enemy, but it is much better to just keep things a little bit more organized. So I will start off here creating this object. So I will right click on the objects folder, create, and I will create a new object. I will call it obj underscore manager. And now to declare these variables, I will just use the create event, okay, that is called as soon as the game starts. And here, of course, I'm going to use in GML code, and I will enable this option. Don't ask again for this project, since for this course we are just going to be using the GML programming language. And over here, I will start declaring these variables. You create these global variables by writing global dot and now the name. So we're going to have some variables here that maybe right now they don't really make sense, but well, as the course goes by, we're going to sometimes be using these variables, okay? So right now we'll just declare them, and as the game, as we are creating the game, we will refer back to these ones, okay? So the first one is going to be frame rate, okay? And this is going to be equal to the current frame rate that the game has, okay? This is going to be useful for when we want to call the different alarms, okay, in the game, and just to make sure that every single alarm is being called at the exact same rate in spite of the current frame rate, okay? Once again, do not worry if you don't completely understand this, because we will get back to this when we need to. But well, here what you would do is do game get speed, and here game speed FPS, okay? So here you would actually get the current frame rate. Then I will create other global variable that I will call global.units margin, and I will make this equal to 20. So what is going to happen is that I will disable the grid, okay, so that I can move my things a little bit easier, because if not, with the grid it is a little bit more complicated. So what I want to do for my enemy pathfinding system and also for my player, I want to have some space in between this player, because if not, if when we want to move, for example, the enemy towards the player, what is going to be happening is that the code what would do is to match completely both positions, okay? So the enemy would be over the player. So this unit's margin would actually leave some margin between the units. Something like 20 is going to be maybe something like this, okay? So it's going to actually look much better. And once again, this is something that we will use when we actually get to code the movement, okay? So don't worry if you don't understand this. Now this one you will understand it because it's basically game over. This will determine if the game is over or not. Now I also want to store the viewport width, okay? And to actually know the viewport width, I have to do view underscore viewport of width, okay? And here 0, okay, because it is the first viewport, okay, the only one that we have enabled. And I will do the same thing but with the height, okay? So I will do viewport height exactly like this, and here h, okay, because I want to get the height of it. Lastly, once again, in order to create our pathfinding, we're going to be needing two things. First of all, a path, okay, that at the beginning it is just going to be no one, okay, basically empty, and then we are actually going to be assigning a path when we create it, okay? But here we are just initializing this variable, initializing the path, and then we will actually get to create this path. And also we will need the grid. So when we get to create the enemy pathfinding system, it is going to make much more sense, and I will explain more what a grid is. But basically this will allow us to break the room into different smaller pieces, into grids actually, as if they were these tiles, okay? And then this will actually allow us, this is a parameter that we need in order to create the pathfinding, okay? Because this grid will detect which zones are walkable, which zones can be walked by the units. Because for example, in the grid we would detect that, okay, this is the wall, so the player shouldn't be able to walk in this place. So that's why we are using here a grid. So you would use the method mp underscore grid create, and well, this requires a tons of parameters. So first of all, it requires us to provide the left of the grid. So in this case, the left of the grid, it is just going to be our 0, okay? And the top of the grid, it is just going to be 0 once again. So the left of our grid is going to be 0, that is this position over here, and the top is also going to be on this position, okay? So we're basically initializing the grid at the top, okay, at the top and at the left of our room, because we want to create the grid in a way that it will cover all the screen, all the room, okay? And then we have to determine how many cells we are going to be having horizontally and vertically. In this case, we are going to be doing for the horizontal cells room width divided by 16, and then room height divided by 16, because we want to break down the room in cells of 16 of width and height. Because basically, if you remember, our actual tile set had a width and height of 16, okay? So this will basically allow us to have the most accurate grid possible. And finally, for the cell width and height, here I have just told you this, our cells, I want them to be 16 by 16. Once again, we're going to get deeper into this when we actually start creating the enemy pathfinding system. However, even though this code like this, it is going to be working and it is more or less quite good, there is a way in which we could actually write this a little bit better, okay, by using scripts, okay, instead of just an object. Because, for example, there are some things that we are just initializing, such as here we're just initializing these two variables, and we aren't assigning any kind of special value that needs the room. For example, here in the viewport width and height, we really need to have the room completely loaded in order to access the viewport width and height. So it is okay that we have it inside of an object, because this object of manager will actually exist in our game. In reality, I will select here the instances layer and I will drag and drop it over here. So this object does have access to everything that has to do with the game. So it does have access to a viewport width, height, etc. But well, we will see a pretty small improvement that can be done in this system of declaring global variables in the following lesson by using scripts in GameMaker. So I will see you there. Hi there and welcome to a new lesson. In this one we are going to be taking a look at scripts in GameMaker, okay? So that we can basically write this code even better than it is currently here. Even though it is quite good, it is quite a good practice as it is right now and it would actually work, we can even make it better. So let's start off creating this script. So we'll simply go to the scripts folder, right click, create, and here I would select script. I'm going to be calling it scr init, and I will just delete these lines over here. So the main difference between a script and an object is that the script that is loaded in before the actual rooms are, for example, created, before of course the objects are created. So it is previous to literally everything that has to do in the game. So what happens with scripts is that, for example, they do not have access to the viewport, okay? So if we called this line in the script over here, it will throw an error. Basically, when we wanted to access any of these variables, it will throw an error. For example, I will do here show debug message. So basically this will print out the value that these variables have. So I will just try to print here the viewport width, for example. So I'm going to run the game. And even though the game seems that it is running correctly, as you can see, for example, I got here no message, okay, with the global viewport width. If you check over here, so it means that there is actually no value inside of it. Why? Because the viewport wasn't even created, so this variable isn't actually having any kind of value over here. And the thing is that the variable isn't even initialized, okay, because as you saw, we had no value printed out. So if we actually wanted to access this variable in other place, we would be creating the variable and not initializing it in the first place. So basically what we have to do over here, I will delete this line by the way, is to know which global variables we should declare in the manager objects and which global variables we should be declaring in the manager. So in the manager, you should only be declaring those variables, those global variables that would need at some moment some reference to some elements that has to do with the game itself, being the room width, the room height, something that has to do with the viewport. So this means that, for example, I am going to be leaving these last 4, okay, in the manager, because as you can see, they all access something that has to do with the game itself. For example, here the viewport, here the room width, okay, and remember the room doesn't exist when the scripts are initialized, and the same thing with the viewport, they don't exist. And I will also leave the path over here, because then I will load in a specific value for the path. So I am just going to be leaving it there. But what I'm going to be doing is to cut these 3 variables over there, and I will paste them over here. So I will initialize them over here. And by the way, frame rate here, the game is initialized, so the script does have access to the current FPS, or well, not to the current FPS, but to the aim FPS that are set in the game settings. And also here I am going to be copying here viewport width and height, and I will paste them over here, and I will just initialize them as 0, okay? So I am actually initializing the variables in the script, and then once they are initialized, because remember the scripts are called before objects are created or even the actual rooms are created, well, when the room is created, I will assign the value to the variable, okay? And also, just because I think that is going to look a little bit better, I will move these variables to the top, okay? So here you have the actual conclusion. You should initialize your variables on the init script, and then in the manager you would actually assign some values to those variables if it is the case that the assignment that you want to do has to do with some elements that only exists once the game is actually loaded in, such as the viewport width on or height, or the room width or height. And with this lesson is finished. Hello there and welcome to a new lesson. In this one we will create the walls for our game. So what is going to be happening is that when our units are going to be moving around, for example when the enemy wants to chase the player, we want the enemy to dodge, okay, the wall, okay, in this case the thing that we have here, the obstacle that we had drawn over there. So for example, if the enemy wants to chase this player, the enemy shouldn't be able to do this, okay? It should detect that here it has a wall and it should do exactly this, okay? And at the same time, for example, let's say that the player is over here, the enemy is over here. Well, the player, for example, shouldn't be able, that we are going to be controlling ourselves, shouldn't be able to move into this position, for example, because it is out of the screen, okay? It is out of the borders of the background that we have drawn. So we are going to actually be defining those borders. So let's start off by creating a brand new sprite. So we'll right click over here, create sprite, SPR wall, and at the same time I will need an object, okay? So I will right click, create object, obj wall. Now I will simply drag and drop the corresponding sprite. And now for you to understand this, why are we creating both a sprite and an object? If the wall, it is not something that the player is actually going to see. The player, of course, is going to be able to actually see these tiles, okay? But it is not going to be able to see the actual walls, the actual collision, let's say. So that's why we are creating an empty object, let's say, that has no sprite, that has no drawing inside of it, okay? The sprite is completely empty, because that's the reason why we are not drawing anything. Because if the sprite had here, I don't know, a blue background, then all the walls that we are going to be creating would be blue, and that wouldn't actually be okay. Let's actually put this into practice so that it is a little bit easier for us to detect. And first of all, I have to modify the size, because as you can see here, it is 64 by 64, but remember that our tile size is 16 by 16. So it is going to be much easier to always play around with the exact same tile size. Because, for example, if I drag and drop inside of the instances layer, the obj wall over here, as you can see, you are not going to be able to see it, but when you select it over here, you are. And as you can see, well, if I wanted, for example, if I activate here the grid and I wanted to position it somewhere, it is going to be a little bit complicated, okay? And if I wanted to modify, I don't know, I only want to add this tile as a wall, it is going to be a little bit more complicated since I have to resize it a little bit. So that's why it is much easier. First of all, let me delete this wall, to just go inside of the wall sprite, and here on this resize sprite option, you would be able to scale the image to something like 16 by 16, okay? And you can just click here, apply. And now if we come back here, and I will drag and drop here a wall, as you can see now, it matches perfectly the size of just one tile, so it is much easier to position and move around. And by the way, I will decrease the size of the grid to 16 by 16 once again to follow all the exact same tile size. And now I am able to position these walls wherever I want. I will delete this wall, by the way, and I will create a new instance layer just to keep things organized, okay? Because this instance layer, I will call it walls, okay? And I will move it just below my instances to keep things organized. And making sure that I am inside of the walls layer, I will drag and drop here one wall. And I will start painting around, let's say, in all the spaces that I wanted to have these walls, okay? Places where the units wouldn't be able to walk around. So I will once again make sure that the grid is also 16 by 16. And now I will hold down Alt, okay, while I am pressing just the left click, and this will instantiate even more walls. So I'm going to be able to create these borders much easier. So I will paint around all this area over here as well, because here these are all places that the player shouldn't be able to move around. So over here and over here, okay? And now, by the way, what you can check is that if you went inside of the wall sprite and then you click here, edit image, and using, for example, the bucket tool, the fill tool, you paint it, I don't know, pink, for example. This is what the player would see, okay? And of course, we don't want the player to see this because it looks awful. So that's why basically the sprite has no color, no anything. So you see here the rubber, okay? We'll just delete all this. And also we have to make sure that we have walls in our obstacle. So I will select the wall once again, and I will make sure that I'm inside of the instances layer. I am holding down Alt, and here I am painting with these walls as well. And with this, the walls are finished, okay? So they do have collision, they do have this shape that will avoid the units from moving on top of here, okay? So if we have the enemy is not going to be able to move on top of this thing, and it's not going to be able to actually escape from the background. And now, yes, everything that we have been doing in the past lessons, we will start using it in the following, since we will start creating the actual enemy AI pathfinding system. So I will see you there. Hello there, and welcome to a new lesson in which we will start creating the enemy AI pathfinding system. First of all, inside of the units folder, I will go ahead and create a new object that I'm going to be calling obj unit parent. So basically, what parents allow you to do in GameMaker is that everything that we create inside of here will then also be happening in the children that we assign, in this case the enemy and the player. So let's open up here the parent menu, and here on children we can add all the child. So I will add both the enemy and also the player. And also over here on variable definitions, the first thing that I will do is to add a new variable that I will call isPlayer. This is going to be a boolean, and by default I will just disable it. And now what I will do is that, as these two objects are a child of the parent, if I go to the variable definitions, I find the isPlayer variable. So I am inside of the player object, so this is the player, so I will make this true. Okay, so now you see how the unit parent had a variable defined, and I was able to access it in the player. And also I am able to access it in the enemy, okay? But this is okay that isPlayer is not true in the enemy. So basically this will handle everything that has to do with the units, its movement, and more. So let's start off by using the create event, and I will define also some other variables. For example, I will declare the velocity, that is going to be 1, okay? And also I will need the target enemy, that is going to be no one by default. but well, then we will actually define the target enemy when we need to, okay? Now what we are doing here is that we are setting the same velocity for both of these objects, for both the player and the enemy, but I want my enemy to move a little bit slower. So what I will do is to firstly update the events tab. So I will just close it and I will open it up again, and now I do see this creates event that is the same one as the unit parent because it is inheriting those lines of code. So if I right click over here and I click inherit event, I will erase this. Basically, as you can see, it says here event inherited, and now I could do here velocity equal, for example, 0.5. So it is inheriting, in this case, both the velocity and target enemy, and I am just modifying the velocity to move a little bit slower than the player. I will start creating the main function with move with path, okay, basically that will allow us to create this AI pathfinding system. So to create a function in GameMaker, use the function keyword followed by the name of the function. So we'll call it move with path, okay, basically with AI pathfinding, but well, to make it a little bit shorter, and then parentheses, and then basically these other symbols, okay, and inside of here you would write your code. Now this function, we have actually a lot of parameters that we are going to be needing. Well, not actually a lot, but 5. First of all, we're going to be having the object x and y, basically the position of the object that is calling this function, basically the x and y position of the object that wants to move, okay. So I will call this argument object x and object y, and then I also want to have the target x and y, basically where do I want to move to. So I will call it target x and target y, and I will also provide here finally the speed at which I want to move. That it will actually then just be the velocity variable that we created, but well, we are just providing it here as an argument. So the first step that we have to follow is basically adding the object wall to the grid, okay, that we had created some lessons ago. So to actually create this grid and to add something to the grid as an obstacle, as something that cannot be navigated, we use mp underscore grid add instances. Here we firstly provide the ID, basically the grid, that is global.grid. Then what object do we want to add? In this case, obj wall. And the last argument is prec, and this determines whether the check is based on pixel perfect relations that are a little bit slower, or if it is bounding box in general, that if we set this to be false, it is going to be a little bit faster. I will just make this true over here, just to make sure that we get the most accurate results, okay? Now, here we have assigned the grid correctly. We have added the wall to the grid, okay? But now we have to create the path. So remember that we also have this global.path variable. So we need to initialize this path, and to do this we do path add, okay, as simple as that. And then we have to merge both the path that the object is going to walk through, and then the grid that will have in count these collisions that we have added over here, these instances that we have added. So we will do mp grid path, and here we firstly need to provide the grid once again, then the path. Now we need the y start, the x start, the y start, the x goal, and the y goal, and we are having here this as arguments, okay? So I'm just going to be using this, so object x, then object y, target X and target Y. And the last parameter of this is allow that basically this will allow for diagonal movements, and in this case we do want to allow our units to move diagonally. Okay, now having all this data, we're going to actually start the path, okay, so that the player actually starts moving aware, also the enemy. So here we have to provide the path once again, global.path, then the speed at which this is going to be moving. So this is where the speed argument enters. What action do we want to perform once the path is finished? Basically, when, for example, we say that we want to move the enemy to the player, okay, so what's going to be happening once the enemy reaches the player? In this case, we just want to stop moving. So we can do path action. And well, actually, you have here lots of options, but I will just do stop. And then here in absolute, I will just make this true. I don't want to complicate this even more than it is. Here you can read the explanation that, well, it may not be so clear, but well, here basically it says if the path is absolute or not will determine if it will just be as in the editor. Basically, if it wants to move the enemy to the player, as we see it here, and that's how it's going to be calculating the path. But if absolute isn't true, if it is false, well, then over here, let's go back here again. If not, it's going to be relative to the current position. So this may lead to some inconsistencies, okay? So we don't want that. So to always make sure that the unit is following the enemy as accurate as possible, the best practice is just to make absolute true, okay? Now I also want to use a little bit the unit margin that we have defined. So first of all, if the current object isn't the player, I want to be using this margin, okay? And what I want to do is, if there is a space, okay, between the object and the target object that it is not, that it is smaller than the margin, okay, I just want to end the path so that they don't continue moving. I just want to stop the path. But well, we'll actually get deeper into this and more of this system in the following lesson. So I will see you there. Hi there and welcome to a new lesson. In this one, we'll continue with the enemy path finding. So here what we want to make sure is that the enemy is always leaving some space with the player, okay? Because if not, what is going to happen is that when the enemy is moving towards the player, it will always make sure to match its position with it, okay? And we want to always make sure that there is some space between the player and the enemy. Something like 20 units seems like a good value. So, and those 20 are stored in the script, okay, in this variable. So, what I will do over here is that as I want to detect this in the enemy, I will check, okay, if this is not the enemy, it means that we are on the enemy. And what we want to do here is to call a method that is point distance, okay, if point distance, basically, what is the difference between the object X and object Y and target X and target Y. So this will basically give us the values, the difference between the object X and Y, that is the enemy, and the target. So this distance, for example, here we see that it is something like 40, and here it could be something like 8, 7, etc. So if this distance is smaller or equal to the unit's margin, it means that, well, we have enough space between them and that basically we should end the path, okay, because we don't want to move anymore. So that's why we are ending the path, meaning that, well, okay, do not move, do not move, okay. Now we want to actually start moving the enemy. So to do this, I have to continuously be updating the path. Why? Because, well, right now the player cannot move right now, but well, it is going to be able to do that soon. So if first of all the enemy calculated a route from its original position to this position that the player is, but what happens if then the player changes its position? Okay, then it means that as the position of the target, meaning the player, has been updated, we also have to update the route, the path that the enemy is calculating. Therefore, we should always be updating this path, at least on the enemy side. So what I'm going to be doing over here, outside of this function, is that if we aren't the player, okay, which means that we would be the enemy, I'm going to be starting an alarm. And here I will start the alarm number 2, because actually the game does contain more alarms. And well, the way in which I enumerated them, you will see how they look, both alarms 0 and 1 in the lessons that are after these ones. So this is just the way in which I enumerated the alarms for the project. So it's not really a big deal. If you wanted to change the enumeration, you could do it, but it's not really necessary. So I'm going to be calling this alarm every something like global dot frame rate times 0.3. So this will make sure that we are always calling the alarm every 0.3 seconds. Okay, this is basically the formula, okay, that we're using here with global dot frame rate. Okay, because remember that in order to call alarms in GameMaker, this works based in the frame rates. Okay, so if you want it to be 1 second, you would call here 60, okay, because by default the frame rate is 60. So if you wrote there 60, okay, it would mean 1 real second. But well, if you have 60 here times 0.3, well, you would then call it every 0.3 seconds, or well, in 0.3 seconds of real life. Okay, now and actually, by the way, this can be easily understood by doing this. For example, if a global frame rate is 60 and we want to call it every 0.5 seconds, okay, we can verify this formula multiplying it by 0.5, and we realize we have 30. Okay, that would be the normal value that you would write without using a global variable. Okay, so now let's add this alarm number 2. And in the description, I will just write over here, update enemy path. And first of all, what I will do is to check if the game is over. I don't want to be moving anymore. I do not want to update anymore the path. So I will just call return. And now remember that in order to move with the path, we have to determine the target. And which is going to be the target of the enemy, basically the nearest player. And to do this, we are going to be creating a new variable that we call nearest player. And this is going to be equal to instance nearest. Okay, here we have to provide our current x and y, and then the object that we want to find, in this case player. Okay, so here we are finding the nearest player, and now we can actually move with path. So our object x and y is basically our current x and y. Then our target x and y is the nearest player dot x and the nearest player dot y. And finally, the speed at which we want to move is our velocity. And finally, we want to always be updating this enemy path. So I will do alarm 2 equals global dot frame rate. In this case, I will multiply by 0.5. So initially, the alarm is going to be called quite soon, just at 0.3 seconds, and then it's going to be every 0.5 seconds. Okay, this is just so that at the beginning of the game you don't have to wait so much time, because 0.5 seconds could be a little bit too much. Well, here every 0.5 is going to be enough, and also the more times that you are calling this and that you are updating the path, the more resources the game needs. So well, 0.5 I found that is a value that actually works quite well. And now when you click play, well, you will see this room that, well, doesn't have the player, the enemies. So this is just because we have the menu that doesn't have a play button, a title, or whatever. And this basically we have defined it here as the main room, basically as the first room to be played, as basically it should, but well, we don't really have the play button yet. So momentaneously I will just change this to play firstly my room game before my menu, just so that every time that I run the game I get the room game played first. Well, when I actually create the main menu, I will make sure that the menu room is played before everything. So now we do see the three enemies moving towards the player, and as you saw, they dodged the wall, okay, that we created over here. So you can check, for example, this one over here, also then this one. So indeed it works as it should, and it is also keeping that margin in between the player, okay. So it means that indeed everything is working as it should.